Hello again, my fellow subscribers. I'm just amazed at the wonderful news we've got because this channel has grown so much in the past 2 weeks. We are now almost at 500 subscribers. Can you imagine? I feel so blessed. And I really want to thank everyone who has been participating on my channel for such a long time. It really is a blessing to share mathematics with so many eager young people in particular who have, for whatever reason, have had a very hard time in school. A lot of my subscribers have been letting me know in the comment section that you've either been, neglected at school, your teachers are not explaining things correctly, or in fact, in some cases, I've even seen that some of you don't even have, some of your instructors are not even mathematicians, just as I predicted last week was going to happen. But anyway, I'm not going to get into that. It's not a time in this video to be negative about something, even though you always, I'm of the philosophy that in order to solve a problem, we have to address the problem. But this particular video is one of my subscribers has asked me to do a series on the law, the trigonometry law, right? And in this particular one, we're going to talk specifically about the law of sines. It's kind of like what I did last week or the week before, if I recall correctly, which was an emergency video in case you're taking a test and they're specifically testing the law of sines. We're going to look at it, do some problems with that, and then in my next video, we'll talk about the law of cosine. Now, typically, and of course it varies by school, it varies by instructor. If this were my course, I would actually be teaching the law of cosines before I do the law of sines. A lot of instructors don't like that because they find it more practical to teach the law of sines before they do the law of cosines. It's just better looking for some. I mean, to me, old math is beautiful, but for some instructors, this actually is more appealing. It's easier on the eyes, or it assumes less knowledge, less algebraic manipulation knowledge. So we'll start with this anyway, because someone had asked me about the law of sines. And typically, it's very important. Well, I'm going to try and draw. I'm a very bad drawer. I'm warning you. But I'm going to try and draw a triangle and kind of give you the information you need on this. We'll try it this way. All right, it doesn't look the best, but let me see if I can make this line better. Sometimes it assists me. All right, well, it's okay. But basically, if this was triangle A, when you're dealing with the law of sines, by the way, it's very important that you put when we're talking about the angles themselves, they go in capital letters, typically, right? And so this could be A, we'll call this B. What's this? Points, angle C. And then what is very important is that you make sure that the sides are in lowercase if you're taking a test, and you put opposite. You're going to do opposite to the angle, right? So if this is angle A, side A is going to go that way, right? So it's going to have side A right here. You see how I put in lowercase? So the next one, if I have angle C here, my C is going to be on the bottom, right, opposite to it. And if I have angle B, well, B is going to be obviously on this side. By the way, from this, you can actually prove the tangent law as well. But I don't want to confuse anybody. And as I said, I'm going to be starting a series also on proving these laws, because we haven't proved anything. And I don't like you to just take my word for it. Never take an instructor's, in math, we don't function that way. No mathematician just takes your word for it. It's not because your teacher says it or because your professor says it. It's because these laws come from a proof. There are fundamental proofs of something. So when is the law of sines used? Well, typically, you've been dealing with right triangles, but triangles and real life in general is not always so neat. And so that is when if you know the opposite angle, if you know another angle, and if you know the opposite angle to that side, then we can use the law of sines. And the important thing is to remember to use, I put it on the top here of the screen, A over the sine of A equals B over the sine of B equals C over the sine of C. That is the law. That is the law. You do not have options outside the law when it comes to these principle. So what I'm going to do now is I'm going to draw another triangle. So this is, if you copy this, you can pause the video and you can copy this, but I'm going to go fast. But basically, we'll do examples of them. So let's say you had a triangle, we'll call, again, ABC. And we'll call this A. We'll call this angle 60 degrees. And of course, we'll call the other side, the opposite. We're going to call this side A. We're going to say that that's equals to be 7. Could be whatever measurement. We'll just say centimeters. They tend to be using the metric system nowadays a lot. I guess it's the trend to be more global. Then we have here 45 degrees. We'll call this one angle B. And we'll just say 45 degrees here. And of course, B is going to go on this side. And we'll call this C. And the opposite is side C. So we want to find out, first of all, the value. I'm going to use red. So we're missing this angle here. Right. So first, we have to find the, you notice here, we're missing things. We're missing things. So we're missing two sides, but we do have one side and we've got two angles. So we can use the law of sines. But first of all, we have to figure out what angle C is. And of course, you know that inside every triangle, the measure of the angles is 180 degrees. So that's simple then. We already have 60, we already have 45. So we're going to subtract it. If we do 180 minus 60 minus 45 degrees, we're going to get a total of 75. 75 degrees. Now, so I can put that here now. Now I've got all my angles nice and neat. Now we can apply the law of sines. We're going to use, well, we have A, right? We have side A, don't we? And we have the opposite of that. So now we have the A over the sine of A equals B, because over the sine of B, we have an angle there, don't we? And this looks like, it should look familiar to you. This looks like a proportion, doesn't it? So if A is equal to 7 centimeters, and angle A is equal to 60 degrees, and angle B is 45 degrees, we can actually create a proportion. And you remember from school, proportions, when you have fractions of some kind that are equal to each other, you can cross multiply. So now you have 7 over, I'm going to put it on the right side so you can see. You now have 7 over the sine of 60 is equal to B over the sine of 45. All right. And if that's the case, then that means if we're solving for B, we have B is equal to 7 times the sine of 45, right? Cross multiply. Sine of 45 degrees. And we're going to do over the sine of 60. All right. And I'm going to work it out on paper. I don't use, if you have a calculator, you can do it, but I'm going to work it out on paper and see what you come up with. You can pause the video. Right. Let's see, 7 times this. It's going to give me. I'm going to divide this And I should be getting approximately from my quotient here. It's going to be a decimal, but it should be around 5 point. It's going to be, this is the sine, and I multiply it and I divide by the sine. It's going to be like around 5.7. 5.7 centimeters. But you can check just in case. Now, this gives us side B, right? So now I go back to the triangle and I plug it in. And I have 5.7 approximately. Okay. Now, what else is missing here? We're missing side C, aren't we? So then if we solve for C, we now have A over the sine of A we can use. Equals C over the sine of C, because that's what we're missing. And we do have the value of A. The value of A is 7, as we said before. So this becomes, and we have the sine of A. So we have 7 over the sine of 60. Which is equal to C over the sine of 75 degrees. Very important. Sorry about my 5. All right, so now you have another proportion that you can deal with. We're going to multiply 7 times the sine of 75. Divided by the sine of 60, of course. And if you do your manipulation, see what you come up with. But this is how you would set up a problem with the law of sines. You see, it's just basically, so it's literally a proportional. Why? Because we are dealing with proportions. The sides are proportional in that sense to the angles, if you'd like rather remember it that way. That wasn't too bad, was it? Now, I do have a triangle for you to look at. When you erase this, if I may, you can always, I always say, you can always pause the video if you need to digest everything. All right, what if you had the following? All right, this triangle here. Now let's see what you can do. I want you to find the missing parts of this triangle using the law of sines. Pause the video, and then when you're ready, we're going to go over it. All right, so now, by now, you should have gotten approximately for side B, you should have had approximately 10.3 or 10.29. For side C, you should have gotten approximately 17 centimeters, approximately. So how do we do that? Well, again, we're missing angle B, but we do have angles A and we have angle C. So 180 degrees. So let's start with our workout here. 180 minus 88. Minus 55. Right? And that should give you your total, your angle total, which is going to be 37 degrees. All right, so I'll go ahead and label if the diagram lets me. Yeah, we have here 37. And now we can use the law of sines because we now have A over the sine of A. And we could use, remember that the opposite angle here, A is actually, side A is 14, right? So we could use A over the sine of A equals B over the sine of B. And so if we do B, we can then do B over the sine of 37, right? So let's do that. B over the sine of 37 is equal to 14 over the sine of 55. And if you do the workout from here, that is how you get the value for B. For the value of C, well, you have A over the sine of A, but you also have, you have side C, but the opposite angle is sine of 88. So we could do C over the sine of 88. And we could set that equal to 14 over the sine of 55. And get our ratio, get our, so when we do the cross multiplication here, we now have it set up to be, if we solve for C, it should give you around 17 point. I rounded it to the 10th place, 17.1, but this is how you would do it. All right, so I hope that that makes sense. Let's do a couple more problems with that. And I wanted to show you something as well that comes up sometimes, because students have asked me if they are using, depending on your instructor, you might be allowed to use a calculator. There's a function on your calculator that we can look at. So, for example, let's say you had a triangle that gave you, this was a problem that someone had shown me last semester from a test that they had. All right, they gave them something like this. All right, it says given sides A equals 10. So I always label everything. So let's start doing that. A is equal to 10, B is equal to 5, and angle A, this right here, is going to give me 100. So we have to find the corresponding value for angle B. Okay, so if you get a problem like that, well, basically, the law of sines has to be used here. And one way to remember why is you have side, angle, side. So you can, again, set up your equation, A over the sine of A equals B over the sine of B. That's going to be your ratio. And if that's the case, you can substitute then you use substitution of the known values. You have 10 over the sine of 100, right? Because this is opposite to the 10. So you have 10 over sine of 100. Set that equal to 5 over the sine of B, right? 5 is opposite to B. All right. Now you cross multiply. 10 times the sine of B is 10 sine B. You see why algebra is so important? Because it's used a lot. Sine B. And now we have 5 times the sine of 100. And if that's the case, you divide on both sides by 10, since you want to isolate for sine of B. So if I divide on both sides by 10, I get the sine of B by itself. 5 divided by 10. That's going to give me 0.5. 0.5 times the sine of 100. Now, if for me, right, it depends on your instructor. For me, this is good enough, but some instructors want the actual degrees. And I, by the way, I say that that's good enough for me because I normally don't use I told you, I think I don't normally, I'm not in the habit, I'm a pure mathematician and we're not really in the habit of using applied math contraptions like calculators, not because of anything personal against it, it's just this stuff is not a habit for me. But but I do know obviously how to operate them. If your instructor wants you to give the angle and you are allowed to use a calculator, then you have to take the inverse, what we call the inverse sine, to obtain the desired angle. So there's a little function on your calculator that it says sine, and then it looks like an exponent to the -1. So if you were to do sine to the -1, just like that, you can see the key on your calculators. And it's going to be, you're going to take the sine of -1 of 0.5 times sine of 100. And it should give you a decimal. It should give you about, if we rounded it, it should give you around 30 degrees. 30 degrees as they a little, not exactly 30 degrees though, just a bit under. All right. So that's another thing that may come up. So let's do another one that we can look at. So what if you had a triangle that looked like the following? Okay. And for this one, we're going to say side A, actually angle A, they have it as, so 35 degrees. All right, so we're going to say 35 degrees for A. And angle C is going to be 93. And then X is going to be 49. So this was a student said that he had a test on something like this. And he was very confused because he didn't know the law of sines. And so the question the teacher asked him was, what is y to the nearest 10th, th, right? So it's going to be a decimal. So if that's the case, right, we have to solve for b. As always, we have to find one of the angles. The sum of of angles in a triangle is always 180 degrees. So here, your missing angle, if we have 35 and 93, and you need to get 180, your missing angle is going to be 52 degrees. So now we have B equals 52 degrees. These are all degrees. And now if you use the law of sine, you have the side opposite A. You're still using the same ratio, but it's the side opposite A over the sine of A, etc. So we could do X over the sine of C. Right? In this case, it's X. Is equal to Y over the sine of B. And this becomes really easy now because you have 49 over the sine of 93 is equal to y over the sine of 52 degrees. And then you would just solve your proportion. You would solve for y. That's all it is. I'll share one from one of my tests that I gave last year in one of my trigonometry class. Some schools call it pre-calculus. I don't like the term. It's really trigonometry, but because our focus was the triangles. But see if I can show you. It shows up on my screen. Okay, here we are. So the question here was I asked students to work out the value of x, right? And to give the answer to one decimal place. So we can use, again, the law of sines. We have x over the sine of 38, right? The opposite to x is 38. Always look at the opposites, right? That's how you're going to know this. It's a proportion. I keep insisting on that. So you have x over sine of 38 is equal to, and then we have 13, right? We could do 13 over the sine of 100. You see how generous I was? I even gave them the two angles, but 13 over the sine of 100. And now you have 13 over the sine of 100 that you can multiply that by the sine of 38. So basically, so again, it's still the same proportion, and I'll let you work it out, but that's the theory behind it. So I hope this makes sense so far, hopefully. Let's do one more, actually, one more. Again, also from my test last year. It was a basic skills test. Okay, so we're solving this one. This one right here. So the angles here were 55 and 20. So we did 180 minus 55 minus 20. That gives you 105. And from here, we wanted to work out the length of AC, right, where that x is. So our only choice is to look at opposites. X over the sine of 105 is going to equal it's going to equal 12 over the sine of 55. Right? As you can see here. So this one kind of looks, and then you would just work out for x. So if this video was helpful, I hope that clarified things on when to use the law of sines, right? It is when you don't have a right triangle, and when you have when you have two angles and a side, you're going to have to work it out in this way. In our next video, we're going to talk about the theorem of the cosine theorem, the law of cosines, which is a little bit messier, but not hard. It's just, it looks different. Thank you once again. Please, if this was useful, I keep encouraging everyone, please subscribe. Help this channel grow. We are helping students. There's a lot of deprived students in this country and around the world. They're not getting the education that they deserve, the education that they both deserve and that they need. So let us help me continue to grow the channel so that I could do more things with you, and enjoy the rest of your day, and happy studying.